Yes, another important point in RTOS we are going to discuss. We already discussed. Then even though you can repeat this multi-processing and multitasking. These are most important in RTOS. First, we will define what is multi-processing. Multi-processing, it is a process. A single computer can be processed more than one programs, which is known as multi-processing. And come to the another point, multitasking. Multitasking means more than one task are executed one after the another according to the priority based. That is known as multitasking. These are most important and most efficiencies improved the programs in RTOS. So there are how many multitasking can be divided into several types. Number one is cooperative multitasking. Second one is primitive multitasking. Third one is non-primitive multitasking. Then clearly we can define cooperative multitasking. I will give an example. If the task is operating in a computer in RTOS systems, then another task is requested to execute. What happens here? First processor, whatever the executing first task is, temporary halt and allow for the another task according to request. That is known as cooperative multitasking. This is also most important because some persons are executing their task without priority based. They are requested to the cooperative multitasking systems. Then they are executing their own program. And first one is temporary halt. Then it will start after the completion of requested task. So that is known as cooperative multitasking. Then another type is primitive multitasking. Primitive multitasking is also same as it is also executing the task according to the priority base. Kernel which is provided the priority, time schedule, everything. Then based on the priority, primitive multitasking processes takes place. Similarly, third type is non-primitive multitasking. This is until it is terminated. Suppose one task is executing in a RTOS system in a CPU. After completion of that particular task, then only it allows for the second task. This is known as a non-primitive task. These three multitasking level is very essential in RTOS. Then another important point is task communication. You are already familiar about communication means synchronization between the transmitter and receiver. So with the help of diagram, see the diagram, shared memory is there, client is there, server is there, kernel in between there, output file is there, input file is there. What is the function of shared memory? Shared memory which is share the informations then it improves the efficiency of the executing speed. So shared memory is most important in case of RTOS. It is increases the efficiency. Then throughput is maximum that is possible in shared memory devices only. Here it is client is send a request, then shared memory store that information and server which serves the whatever the information. That is known as shared memory. Shared memory is most important in the distributed filing systems. So it is improves the speed of operation. Execution speed is maximum in case of shared memory. That's why in task communication they are preferred shared memory devices. Then kernel which is manage all the devices output file as well as input file, server hardware as well as the software. These are the major advantage for this shared memory is it improves throughput and efficiency, execution speed is improved. Then another important point we are going to discuss is pipes. Pipes means a communication in unidirectional. Suppose the information is flowing in the form of pipes. How we will read and write the information at the end of the pipe? We are taking the informations at the end of the pipes, read or write whatever it may be. Then this process is continuous. This is known as a pipes unidirectional communication. Another important point we are going to discuss, that is properties of semaphore. Semaphore is independent. It is not having any control. Then wherever it is appears in the programs. So there are four mechanisms of semaphore. First one is it is a machine independent. It is not depends on the machine. It is generating by the program. And another point is simple to implement. Semaphore is very easy to implement in RTOS programs. And third point is easy to determine. Very easy to recognize if whether the program contains semaphore or not. Very easy to recognize. Then the major drawbacks for semaphore is then anywhere it is developed, anywhere in the program, then there is no control or management system in the semaphore. Those are the major disadvantages in the semaphore. So then we are enter into the selection of RTOS. The person who he is going to the market, then he wanted to purchase one real-time operating system. What are the major criteria he should be concentrate? There are two types of major criteria: functional requirement and non-functional requirement. So in functional requirement, processor management. Processor management, the person who is tested the processor, speed of the processor and all the tasks before purchasing the RTOS or before selecting the RTOS. Second point is discussing memory management. What type of memory is there, what is the storage capacity, how much RAM is there, how much ROM is there, how much cache memory is there. These are all the information should be gathered and collected. And third important selection criteria is kernel and interrupt. Kernel, which type of kernel, then how the capacity to control the input and output devices, and management of interrupt latency. Interrupt controller, all the formalities is tested one by one. Then interrupt program controller and task synchronization. In any RTOS system, IPC and task synchronization is most important. Without synchronization, communication is not exist. So interrupt program controller and task synchronization testing of RTOS is very essential. These are the functional requirement of selection of RTOS. Now we enter to the non-functional requirement, development and cost. Non-functional requirement means production cost. The person is always thinking about the cost of that RTOS and how to use this system, whether it is a operation is procedure is simple or complex, and these are all the formalities can be go through that. In this way the person is select the RTOS. And another point is efficiency and other process depends on the nature of the industry is selecting the RTOS. Now we are entered into the sixth point, integration and hardware and firmware development. So hardware you are already familiar in embedded system, chip VLSI chip designs, then all processor, then all the hardware parts we have to be carefully tested and integrate the firmware, hardware and software synchronization is most important in application oriented systems. And another important point is in-system programming. In-system programming is while you are writing the codes, you have to alter and you have to rewrite the program. That is possible in case of in-system programming. And similarly, third point is in firmware design and development. Now, in application programming, application-oriented program, if you committed any mistakes, or if you want to add, if you want to delete, if you want to subtract something, that is possible in application programming. So, these hardware, software synchronization is most important in firmware developments, in system programming, in application. These are the three most important points while design and develop the firmware systems. Now our important another important point is IDE. IDE means integrated development environment. So in RTOS, to design and develop any programs, so many environment should be most important. So first condition is building an application. Before building an applications, you have to gather all the information related to the problem. Afterwards, you have to build the application. Another important criteria for this is managing the application. So many several types of applications in file system, drives, so input drives, interpretation devices, output devices. You have to be managing the file applications. And third point is configured and building the kernel. Kernel is play an important role in case of RTOS. the configured system configuration, input output device configuration, these are the software, it may be hardware or software. The configuration and control is most important, that is done by the kernel. Another important point is building root file systems. You have to create a file or source file according to the root level. You have to build the file and execute the program. That is another important IDE environment. Then last is debug applications. So any software, it may be embedded system, it requires the debugging tool. Debug and create the object file. Afterwards, you have to debug if any error is there in the program. Afterwards, you have to be run. This is another important point. These are the 5 important points are integrated development environment. Another important point is simulator, emulator and debugging technique. These are most important. Simulation means simulation the hardware. Hardware, it may be circuit diagram or it may be logic devices. Anything you have to be simulate according to the nature of circuit. You have to write the code and execute that circuits and see the output. That is a simulation. Emulator and debug technique. Emulator means what? Whatever the errors are there while at the time of executing the embedded system software, you have to eliminate it, create the object file with the help of cross compiler. You have to debug line by line. So many techniques are there nowadays. They are using the several techniques. They immediately are find out and simulate and debug the any error is there in the program. That is known as debug techniques. Then another important point is assembler and disassembler. Any hardware you have to assemble it, connect properly according to the nature of the circuit. You have to assemble it. Disassembly means what? Some parts you have to eliminate or you have to add or subtract to the some parts. You have to disassemble it, disconnect it and provide the proper connection. This is known as assembler as well as the disassembler. These are also most important. While addition of the hardware, addition of the software, these are assembly and disassembly is most important. Another important point is target hardware debugging. If you want to debug, that certain tools and techniques are there to eliminate the debugging. For large projects, they have a very dense coding system is there. At that time, they are using a sophisticated tool for debugging all these programs, errors, anything else. They are using target hardware debugging. If hardware is scanned line by line or circuit by circuit or component by component, they are tested the hardware. According to that, so many techniques they are adapted for testing of system level software or component levels of hardware. All these parameters are taking into the considerations. Hardware debugging, and also they are testing the memory, how much memory capacity, what are the properties of the memory. All the information should be collected and gathered the information of the same. And last point is boundary scan. Boundary scan is most important and more powerful tool for hardware testing. First it is tested the entire system. Before that it is going component level and then this is chip level, afterwards circuit level, afterwards bit level. In this way continuously scan the hardware. If hardware everything is right, then they are dumping into the software. Afterwards they are sold out that particular product. In this way RTOS is more powerful tool in the embedded system. So this is